So next topic is law of gearing. So this is actually a condition which must be satisfied between two mating gears to obtain a constant velocity ratio. So you know the purpose of gearing is to transmit motion power. So a constant ratio of velocity is required. Now read that statement. The common normal at the tooth profile at the point of contact of two mating gears must always pass through the pitch point. That is, if at the point of contact of two gears we draw the common normal to the teeth profile, that should pass through the pitch point. That is the statement. You know that pitch point is the meeting point of both pitch circles. Okay, that is an invariant point. So let us see how we can prove that, or how we can design. Usually gears will design like that only. Okay, I will show you it. Here the previous diagram used to derive path of contact and all. So just go through the diagram. I already represented not as clear image, a very base circles of both gears and addendum circles of both gears. They are not clear. So for better view of the other lines I made so. Okay, now how you have to start is you have to draw the base circle and addendum circle of 1 and base circle of addendum circle of 2. That's the first step. Then represent the centers C1 and C2. Now what is here, which is the pitch point P? I represented point P, that is a pitch point. Similarly Mn, what is Mn? Mn is the common tangent to both base circles, such that M is a point on base circle 1 and N is a point on base circle 2. So this common tangent is the common normal to the tooth profile, that also we discussed. So Mn is our normal to the teeth profile. So the what is the law? This normal should pass through pitch point. Okay. For that, next okay, you drawn up to C1 and C2. Now you join C1 and C2. After 4 arcs, represent center C1 and C2. Then join C1 and C2 with a solid line. Then C1M and C2N you join. Okay, C1M and C2N join. Then you write, let Q be the point of contact of two teeth at the given instant. Let point Q be the point of contact of two teeth at the given instant. Now then you mark a point Q between points M and P. You have to represent P also. Then between M and P, mark a point Q, such that M and N are fixed points. P is also fixed, but Q is a variable point. At this instant, the point of contact is Q. The next instant, it can be another point. Okay. So up to Q you represented. Then you join C2 and Q, also C1 and Q. Okay. So C2 and Q and C1 and Q. So again next you have to join, you have to draw that common tangent from M to N. Draw the common tangent. I already told to draw mark C1M. Okay, first then you draw the first you have to draw that Mn, then join C1M and C2N. Okay, now your diagram will be like that. I will tell. There will be C1 to C2, there will be a line, then there will be two triangles, C2NQ and C1MQ. Okay, up to this you do. Now next step, velocities of both gears. Okay, now imagine two gears are moving in contact, so that one gear transmit the motion to the other gear. So what should be the condition for velocity? Along the point of contact, both should move with the same velocity, right? The path of contact is mn. So the gear contact is moving along mn. So along mn, the velocity should be equal, right? Now you think why it should be equal. If it is not equal, what happen? If one is higher than other means the contact will be lost, right? So to keep the contact, velocities at any instant should be equal. So next step is to find the velocity of each gear along mn. Okay. For that, you have to draw the velocity directions of both gears. Okay. So first, see gear 1. So at gear 1 now the point of contact is Q. What will be the velocity direction? What will be the velocity direction? Velocity direction will be perpendicular to C1Q, right? You know that definition and all, it will be perpendicular to the link. Similarly here now it is perpendicular to C1Q and is represented as V1. So V1 is perpendicular to C1Q, please note. Then you draw a line to represent velocity V1. Now you add the angle between C1M and C1Q as alpha. Okay, you add angle between C1Q and C1M as alpha. So if that angle is alpha, okay, wait. If that angle is alpha, then what about this angle? That angle will be 90 minus alpha. Okay. This will be 90 minus alpha. So when this will be 90 minus alpha, what is angle between C1Q and V1? That is 90 degree. So the remaining this will be 90 degree. And what about the total angle of this line M to N will be 180 degree. So this is 90 minus alpha and this is 90. So the remaining will be alpha. Therefore V1 will be inclined at alpha to Mn. Okay. Then similarly beta is the angle between C2N and C2Q. Use the same concepts so you can understand that V2 will be, before that. Now velocity of gear 2. Now gear 2 is at contact at C2Q. Now the contact is at Q. Therefore velocity will be perpendicular to C2Q. So you draw a perpendicular to C2Q, that is V2. Then the inclination will be similar to the previous case. Here the inclination is beta, so the same inclination will come here, beta. So the angle between Mn and V2 is beta. So you completed the diagram. Okay. All points you represented. The next you write the expression for V1 and V2. What is V1? What is V? R omega. Therefore V1 will be R into omega. So then you have to add, let omega 1 and omega 2 be the velocities of gear 1 and gear 2 respectively. Then you can write V1 equal to omega 1 into, what is the length? What is R here? C1Q. So omega 1 into C1Q. Similarly V2 will be omega 2 into C2Q. Next, what we require the component along Mn. So what is the component along Mn of V1? V1 is inclined alpha to Mn, therefore the component will be V1 cos alpha. Similarly, other component will be V2 cos beta. So to maintain the contact, both these components should be equal. Therefore, we can say V1 cos alpha equal to V2 cos beta. Okay. V1 cos alpha equal to V2 cos beta. This is the requirement. Now, then you have to find an expression for cos alpha and cos beta. You consider the triangle C1MQ. In C1MQ, cos alpha is defined as adjacent side C1M divided by C1Q. C1M is the adjacent side, C1M by C1Q. Similarly, here triangle C2QN inclination is beta angle, so cos of beta will be C2N by C2Q. So here you see cos alpha, I mark cos alpha as C1M by C1Q, cos beta C2N by C2Q. So note all these. Then after that, you substitute these values to the previous equation. Okay, I'm just directly substituting this. Next step, so V1 is omega 1 into C1Q. Then cos alpha is C1M by C1Q. Okay, so you will get this expression. So C1Q and C2Q will get cancelled each other in both sides. Since, okay, this and this cancel. Sorry. This and this will get cancelled. This and this will. So the equation will be omega 1 into MC1 equal to omega 2 into MC2. Or omega 2 by omega 1. Omega 2 by omega 1 is called the velocity ratio, where omega 1 is the driver and omega 2 is the driven link. That ratio of velocities is called of output to input is called velocity ratio. So omega 2 by omega 1 will be equal to C1M by C2N. Then the next step, so this is the last step is this. So moving to the next step. Next step is consider similar triangles C2PN and C1PM. Okay, C2PN and C1PM. Those two triangles. Now we are including pitch point also, C1MP and C2NP. When we consider these are similar triangle because the side is straight line, you can see C1, C2, C1P and C2P. Therefore, both will be similar triangle. So we can write such that one side take C1M by corresponding side of the other triangle C2N equal to next C1P divided by corresponding side C2P. That is also equal to third side PM by PN. Then what we can write? Omega 2 by omega 1 will be equal to, instead of this M, you have M and N, you have C1P by C2P. Now what is C1P? C1P is the pitch circle radius of gear 1 and C2P is the pitch circle radius of gear 2. Therefore, omega 2 by omega 1 will be R1 by R2 or D1 by D2. And D and T are proportional, so you can write T1 by T2. So these relations put it in a box. And what we can say, R1 by R2 is a constant value. Now you got the velocity ratio as a constant value. Why you got it as a constant value? Because we kept the point P on Mn, on common normal. That's why we got this. If P is somewhere else, we will not get this ratio. Now again you see, now the point of contact is Q. When it changes to R, somewhere else a point R, then also will reach the same equation. If we try to derive, we will get the same equation C1P by C2P. So this is the proof of law of gearing. Okay. If you have any doubt, you may have some doubts. So please feel to ask personally. Okay. So put this in a box. So next heading you write velocity of sliding. Here you have to write, since you obtain velocity ratio as a constant, and that constant is the radius or diameter ratio of pitch circles of both gears. So such a final statement you should make before writing the next. So next you write velocity of sliding, that is a heading. Okay, velocity of sliding. Now what is the velocity of sliding? The same diagram you have to use. You check what is the difference from the previous diagram. Here I drawn a line from V2 to V1 to R. Okay, so what is the change? Now I have a velocity triangle QRT. QRT. So from V2 you have to draw a perpendicular to MN. That meeting point is R, should passing through the V1 at the S. Okay. So QRST or QRT is a velocity triangle. Now QR is the QR is V1 cos alpha. And what is RS? Now I am introducing two more components, RS and ST. Just see the triangle. If QR is V1 cos alpha, RS will be V1 sin alpha. Similarly, RT. If QR also the cos beta, RT will be V2 sin beta instead of cos. So these are the velocities. These are the other two components of your velocities. So you represent this, then we will come back to the velocity of sliding. Now what do you mean by velocity of sliding? Imagine the contact between two gears. When two gears are in contact and moving, what will be the direction of sliding velocity? So in what direction the sliding will occur? Sliding will occur in the tangential direction, right? Tangential to both teeth. In that direction only sliding velocity will move. So you have to find the velocities which is tangential to teeth profile. Now we know that Mn is normal to teeth profile, therefore any line perpendicular to Mn will be tangential to teeth profile. Therefore the component along tangential direction are RS and ST. What is, so the note here VR. So we know that in common normal direction both velocities are equal. Here velocities are different such that V2 component is greater than V1 component. V2 component is RT minus V1 component is RS. That is V2 sin beta minus V1 sin alpha. I already mentioned about it. Okay. So got this expression. Now you have to replace the sine components. For that you have to check the triangle C1QM and C2QN. First take this triangle. You already took that C1QM for cos alpha. Now you do use the same triangle to find sin alpha. What will be sin alpha? Opposite side by hypotenuse. That is opposite side is QM or MQ. So sin alpha will be MQ by C1Q. Similarly sin beta will be NQ by C2Q. Now you substitute both there in this equation. Okay, substitute both values in this equation. So we'll get V2 into MQ by C1Q minus V1 into NQ by C2Q. So we substitute it. Next step you have to replace V2. Okay, this last line is wrong. Okay, this last line, this is not V2 and V1, these are omega 2 and omega 1. Okay, so velocity of sliding equal to omega 2 into NQ minus omega 1 into MQ. that I will tell you what is V2 and V1. V2 is omega 2 into C2Q. Similarly, V1 is, you check the definition, V1 equal to omega 1 into C1Q. So that's C1 and C2Q will be get cancelled. So we will get omega 2 into NQ minus omega 1 into MQ. Now next this equation. Omega 2, here it is correct, omega 2 minus omega 1. Now you change NQ. You know that P is a point between N and Q. Therefore, we can write NQ as QP plus PN. So I write it QP plus PN. Similarly, MQ is a point on the same line such that it is equal to MP minus PQ. Check the diagram and find an expression for MQ in terms of P. MP minus PQ. Then rearrange it. QP is there in both equations. So you'll get omega 1 plus omega 2 into QP plus first equation omega 2 into Pn minus second equation omega 1 into MP. Okay. So finally we'll get velocity of sliding as omega 1 plus omega 2 into QP. Other two terms get cancelled. Why? Okay, that I will see. Omega 2 into Pn and omega 1 into MP. Now you go back, I will go back to one slide. This slide. When we consider the similar triangles to get an expression in terms of P, already I also note this Pm by Pn, the third side. So we can write omega 2 by omega 1 equal to Pm by Pn, or omega 1 into Pm equal to omega 2 into Pn. See, omega 2 into Pn equal to omega 1 into Pm. That means these are equal. Therefore, it will be 0. These two will be 0. So, we'll get an expression for velocity of sliding. Put that in a box. Omega 1 plus omega 2 into QP. Now, what is QP? QP is what is Q? Q is the point of contact of gear at this instant, and P is the fixed point, pitch point. Therefore, the sliding velocity depends upon the distance of the point of contact from pitch point. That is one observation. Please note it. Sliding velocity depends upon the distance of point of contact from pitch point.